Your voice is not like if you are speaking, it is not audible. So I will start the session. You can ask in chat box also. Okay. So
Visible, sir.
okay. Okay. So this is the first question I have taken. Okay. So a lead transfer. Okay, but your voice is not audible. I think your side is speaker will some problem will be there. You can check maybe. Anyway, chat I can see. So anyway, you can type in chat also. Your voice is not audible. Maybe in your system some setting will be required. Maybe audio is not correct. It's okay. So I will start. So this is the first question I have taken. Okay. A transfer function of a phase lead compensator is given. Okay. So this is a standard form of the lead compensator 1 plus alpha ts divided by alpha into 1 plus ts, where alpha is given as 4 and tau is given at 0.1. So this we should remember one standard formula. So what will be the frequency at which the maximum value of the phase lead will occur? So this derivation it already will be derived in the video lectures that you can refer. So the formula is omega m is frequency at which the maximum phase lead will occur. So omega m we can calculate as omega m is equal to 1 by t into under root alpha. So t is given here 0.1. So 1 divided by 0.1 into alpha is given as 4. Okay. So this will be how much? 10 by 2. So it is equal to how much? 5. So 5 radian per second. So at this value of omega frequency, this kind of, if we will draw the Bode plot, so this kind of waveform will come, okay, for phase of the angle if we will plot with respect to omega, phi with respect to omega. So this kind of plot will come, and this maximum will occur at omega m. Omega m means frequency at which the maximum lead will occur. Okay. So by using this formula, we can calculate the this. So this first question answer is 5 radian per second. Similarly, one other derivation is there for the second question. Okay, so maximum phase, how much will be this maximum phase lead? So directly we can calculate this value. So that formula is phi m is equal to sine inverse. It will be alpha minus 1 divided by alpha plus 1. So alpha is given as 4. So that will be sine inverse 4 minus 1 divided by 4 plus 1, which will be sine inverse 3 by 5. How much will be this value? So sine inverse 0.6. Sine inverse 0.6. It will be how much? 53 point. No, no. Is it correct or some error is there? Okay. Alpha plus 1. Uh, Alpha minus 1 will be, I think alpha plus 1 divided by alpha minus 1 it will be. Sine inverse alpha minus alpha plus 1 by 5 by 4 it will be. 1 second. Is it clear up to now? Anyone of you remember this formula? What will be this? Is it correct? This one? 1 second. I will just recheck it from my notes. Already I have written this. 1 second. So for lead compensator, 1 plus Ts divided by 1 plus, okay, 1 second. 1 plus alpha Ts. So, okay. So I have written in other format. In my notes, the formula is in other format. So the lead transfer function I have written as 1 plus Ts divided by 1 plus alpha Ts. Okay, and here it is given as 1 plus alpha Ts divided by. So if this will be the format, so what will be the here? Okay, so 1 second. Alpha will be, so one thing will be common. So alpha Ts is alpha T is tau here. So one second. Sine inverse alpha minus 1. Just we can write the formula in different notation. Okay. But for this one, this kind of function, if transfer function will be like this, then formula will be phi m is equal to sine inverse of 1 minus alpha divided by 1 plus alpha. Okay. Because alpha will be less than 1 here. Okay. But here since alpha is greater than 1 and this is written in other format, this is one format. So this kind of format will be there directly. So we can transfer this into this either, or I think for this one formula will be different. So I think it will be alpha minus 1 by alpha plus 1, 1 only, 4 minus 1 by 4 plus 1. So what will be the value? Sine inverse 3 by 5. Sine inverse 3 by 5. 36.86. Is it clear? Hello? Any doubt is there?
Yes, sir.
Okay, okay. So moving to the next question. Any doubt will be there, you can stop me and ask. Okay, I will explain that again. So this is another question. Okay. So here a open loop transfer function is given. Okay. GS is equal to K by S into S plus 2 and some time response specifications are given. MP is 16.3% and TS is equal to 4 seconds. So we have to calculate the value of K to achieve this peak overshoot and settling time. Okay. So we can write the second order transfer function for this one, G by 1 plus G for unity feedback. So that will be K by S square plus 2S plus K. Okay. And we can just calculate the value of zeta from MP. So MP is equal to e to the power minus zeta pi divided by 1 minus zeta square. MP is equal to e to the power minus zeta pi divided by 1 minus zeta square. This is equal to 0.163. Okay. So ln we can take both sides. You can also calculate the value of zeta. What will be the value of zeta for this one? So we can take ln. So it will be here ln e will be equal to 1. So minus zeta pi, okay, into what will be this value? So minus zeta pi by 1 minus zeta square, okay, is equal to ln 0.163. Is it correct up to now? So from here we can find the value of zeta. We can just square both sides. So zeta square pi square is equal to 1 minus zeta square ln 0.163 whole square. Okay. So from here we can just do left and right. So it will be zeta square. I will take this side. So zeta square will be pi square plus ln 0.163 whole square is equal to ln 0.163 whole square. Okay. And from here we can just calculate the value of zeta. So zeta will be equal to under root, it will be ln 0.163 whole square divided by pi square plus ln 0.163 whole square. How much will be this value? I am also calculating. So
Point
L
5, sir.
0.5 we are getting. Okay. So this will be equal to 0.5. And this one value we have calculated. What is the second value? TS. So TS is given. TS for 2%. What will be the TS will be 4 tau. Okay. For 2% of the tolerance means it will reach 98%. So it will be 4 tau. So it will be 4 divided by zeta omega. Okay. And since zeta is equal to 0.5, so TS already given here. How much? 4 seconds. 4. So zeta omega n is equal to how much? 0.5, correct? So what will be the omega n? Omega n will be how much here? 1 second. Zeta into omega n is equal to 1. and already we have calculated theta value as 0.5. So omega n will be 1 here. Is it correct? Can anyone reply? The value of omega n is correct here, or some mistake is there? Any mistake is there? Hello? Can anyone reply? See, 4 Ts is equal to 4 tau. Up to now it is clear, I think. But omega n we have to calculate, and omega n we can calculate by using the zeta value. So, okay. Zeta into omega n will be equal to 1. Is it correct? Zeta into
Yes, sir. Yes,
from
sir.
this equation, zeta into omega n will be 1, and zeta will be equal to 1 by omega n will be equal to 1 by zeta. So that will be how much?
2, sir. 2, sir.
2. Omega n is 2. So now what it is asking, what will be the k value for this specification? Okay. So from this transfer function we can see that here 2s plus k. So k is equal to what? Omega n square, correct? S square plus 2 zeta omega ns plus omega n square. So omega n already we have calculated. So what is the k value? K is equal to 2s square is equal to 4, correct? So this will be 4. Is it clear? So this question we can solve with root locus also. Okay. So for any desired, let's say some root locus will be there. So for this, I am going to draw the root locus. Okay. K divided by s into s plus 2. So k divided by s into s plus 2. Correct. So the one pole will be at 0, one at minus 2. Right.
Minus 2, sir. Yes.
And number of asymptotes will be how much? 2. Pole minus 0. So somewhere, and what will be the centroid value? So real part of pole is equal to minus 2 minus real part of 0 divided by number of pole 2 minus 0. So that is minus 1. So it will be at somewhere minus 1. Okay. So it will come like this, will come like this, and it will go like this. So this will be the root locus. And as per the desired requirement, we have some requirement. So what is the requirement? This requirement. Okay. So this requirements corresponds to the desired pole. Okay, what will be the desired pole? So that desired pole will be under damped system minus zeta omega n plus minus much omega j omega n into 1 minus zeta square. So for this specification, this MP is equal to 16.3% and TS is equal to 4 seconds. So MP peak overshoot 16.3% and TS is equal to 4 seconds. So for this one, this specification, one desired pole will be there. Okay, ST. Somewhere it will come on this under damped part. Okay, so at this point, what will be the K value? See, some specification is there. How we are converting into a root locus? The first I have just calculated with a standard transfer function. Okay, method 1. How method 2 will work? First, with a specification, some point will be there on the root locus. Okay, so at that point, what will be the K value? That will be the K value of the system. Is it clear up to now?
Yes,
See,
sir. Sir, from this, we have to find the dominant pole, then we have to further
no
proceed, sir.
need. See, here dominant pole concept is not there. So
Okay, sir.
I will
Okay.
explain. So zeta omega and how much we got. So from here, if you'll
Yes.
see, what
Point
is the
0.5 into 2, sir.
zeta omega n? Okay, zero
Point
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 0.5.
one.
So that will be
Yes, sir.
minus 1. Minus zeta omega n. So minus 1 plus minus j omega n how much? 2 into 1 minus how much it will be? Omega n into
0.5
Point
square.
five square.
1 minus 0.5 square. So minus j plus minus j to how much it will be 0.5 square means 1 by 4. So that will be 1 by 4. 1 minus 1 by 4, 3 by 4, correct?
Yes, sir. 3 by 4, sir.
So it will be minus 1 plus minus j root 3. Is it correct? So this will be our desired pole.
Yes, sir.
Our desired pole will be this one to achieve this specification. This requirement is there. So somewhere on the root locus, this pole will be there. Okay. So let's say this is minus 1. Minus 1 is here. And this root 3. Minus root 3. This is our desired pole. So we'll just compute the distance from here to here and here to here. This distance. Okay. So this is here to here, it is 1. And this is how much? Root 3. So what will be this value? Under root 1 square plus root 3 square, correct? Is it correct? Or something
Yes,
is,
sir.
okay, 1 square plus root 3 square. So that will be 4, it will be 2. And k value we have calculated previously, that is 4 na, already. K is omega n square, that is equal to 4, correct? From this equation I have calculated k is equal to omega n square, 2 square is equal to 4, correct? So now here this is 2, this will also be 2, since this is 1 and this is root 3. So this will be also 1 square plus root 3 square equal to 2. So what formula I told, k is equal to product of distance from the poles. So 2 into 2 divided by product of the distance from all the zeros. Okay, so no zero is there, so here it will be 1 and then it will be equal to 4. Is it clear? One other method is there. So magnitude criteria we can apply. What is magnitude criteria? K divided by S into S plus 2 at the desired pole, this should be equal to 1. Okay. If this pole will lie on this root locus and this desired thing is required, then this magnitude should be equal to 1. Okay. So SD is equal to minus 1 plus minus j root 3. This only. So plus j root 3 I will consider. So K divided by minus 1 plus j root 3. Okay. And this will be 1 plus j root 3. Is correct? Equal to 1. This is magnitude criteria I am applying. Okay. So this should be equal to 1. It will be k divided by this magnitude will be 2 and this magnitude will be 2. 2 into 2 is equal to 1 and k will be equal to 4. Is it clear to all?
Yes,
So
sir. Yes, sir.
both the method I have
Please,
explained.
Yes, sir.
please
Yes,
explain root locus method, sir.
okay, see. So the rule is if some pole will be there, okay. So this formula already I explained in the root locus class. So k is equal to product at that point, or no, 1 second, product of the of distance from all pole to SD. Means at SD we have to find the k value at this particular pole. Okay, this is our desired pole. So at this particular pole, from all the poles, this and this is not a okay. This is at this point we have to. So from all the other poles, okay, we'll find the distance divided by product of all zero distance to that point. So if some zero will be there, let's say here zero will be there. So what I will do in that case, this one will be replaced by this distance. Is it clear? See, these two poles are there in our system. Okay. So this formula is k value is equal to product of distance from all the poles to the desired point divided by product of distance from all the zero to the desired point. This is our desired point. Okay. So at this point, we have to measure the distance and multiply. So this is the formula. And since no 0 is there, if no pole will be there, then here it will come all numerator and denominator will be some 0 distance. But since no 0 is there in the system, so here it will be 1. Is it clear? This is directly from root locus we can find the k value. Same thing we can do like this also. Magnitude criteria. This method is only short trick directly from the root locus. Is it clear?
Yes, sir.
Yes, sir.
Okay, okay.
Yes,
So
sir. Yes,
moving
sir.
to the next question. Okay. So one question is asked, what will be the velocity error constant of the system that meets the desired transient specification? Already we have calculated the k value. So g of s will be equal to 4 divided by, what other term is there, s into s plus 2. S into s plus 2. So what is the velocity error constant? Kv is equal to limit s tends to 0 and sgs. Okay. So what will be the this value? Limit s tends to 0, s into 4 by s into s plus 2. So this s will cancel and it will be equal to 2. So for that specification, velocity error constant will be 2. Is it clear? I think simple only. This all of you know this one, velocity error constant formula. In last class, I think already I explained. Should I move to the next question?
Yes, sir.
Okay. So this one. What is the value of beta? Okay. So we are designing a lag compensator. So what should be the value of beta? So beta, how we can calculate that? One formula is there. I think that you can refer to the NPTEL video how it is derived. So beta is equal to, direct short formula is there, kV desired divided by kV uncompensated. So kV desired already is written here. Here kV desired, this is desired value. Okay. And uncompensated, without compensator, what kV we have calculated? This. Okay. So kV desired is 20. Okay. And divided by 2. So this will, beta value will be equal to 10. And the lag compensator formula is G lag is equal to, the standard formula is 1 plus, and 1 second, s plus 1 by tau divided by s plus 1 divided by beta tau. This is a standard lag compensator formula, and desired kV value was 20. Okay. And uncompensated we have calculated kV as 2. So this short formula is there. With that we can calculate the value of the beta. So beta value is 10. Is it clear? Hello.
Yes, sir. Yes, sir.
Okay. Okay. So for next part, same question. With the pole of the lag compensator, PC is equal to minus 0.01. Equal to minus 0.01. So the compensator 0 is located at. Okay. So first we'll write the transfer function, s plus 1 by tau divided by s plus 1 by beta tau. So Gc is equal to s plus 1 upon tau, s plus 1 upon beta tau. Okay. So pole is given. Pole is given means this is pole. S is equal to minus 1 divided by beta tau is the pole. This is equal to minus 0.01. So what will be the beta tau value? Beta tau will be equal to 1 upon 0.01. Okay. And we have to calculate what value? 1 second. So, 1 by tau. So beta is already known. What is the beta value? 10. Okay. Already we have calculated. So 10 tau is equal to 1 by 0.01. So what will be the tau value? Is it correct? What will be the So, but here, what is the zero value? Zero we have to calculate. So 0 is equal to S is equal to minus 1 upon tau. What will be the value of 1 upon tau? 1 upon tau will be equal to 10 into 0.01. Okay, that is equal to 0.1. So 0 of the compensator will be, this 0 will be, so PC, P compensator means pole of the compensator minus 0.01. So one second, wait. So pole of the compensator is minus 0.01 and 0 of the compensator will be minus 0.1. Is it clear? Already beta value we know. This is the standard compensator function. So beta we know means S is equal to minus 1 by beta tau. This is the pole and pole is given as minus 0.01. This is equal to minus 0.01 and beta is 10. So from this equation we'll get the 1 by tau. So 1 by tau will be equal to 10 into, from this equation 1 by tau will be equal to 10 into 0.01, that will be equal to 0.1. So our 0 is Zc is equal to minus 1 by tau equal to minus 0.1. Is it clear? Clear up to now?
Yes, sir.
Okay, okay. So moving to the next question. Okay. So one same transfer function is given. Okay. Unity feet wave. So it is desired to design a lead compensator. We have to design a lead compensator such that the closed loop system has a damping ratio of 0.8 and settling time of 10. Okay. So based on this, the magnitude of angle deficiency in degree. Okay. So for this specification, okay, for this specification, first we can calculate the angle of the system. Okay. So what will be the angle of the system for this specification? How we can calculate? See, already I told that desired pole SD we can calculate from this data. So e to the power already direct I have written here. One second. What is the zeta formula? Ln of mp divided by pi square plus ln of mp square. Okay. So that we can apply here. One second. What will be the zeta value? Zeta is equal to, oh, zeta already given here. So zeta is given here. What will be the settling time is, one second. Ts is equal to 4 by zeta omega n. What will the omega n value? 10. So what is the omega n value? Zeta is given as 0.8. Okay. So omega n is equal to 4 by 8 is equal to 0.5. Is it correct? Omega n is correct or wrong? 0.5, is it correct? Omega n value. So what will be our desired pole for this specification? ST will be minus zeta omega n plus minus j omega n into 1 minus zeta square. Is it clear up to now? Hello.
Yes, sir.
So that omega n value is 0.5 and zeta value is 0.8. So 8 into 5, 40 by 100. So that will be 0.4. So this will be minus 0.4 plus minus j 0. How much this is? 0.5 into 1 minus 0.8 square. Okay, 0.5 into 1 minus 0.8 square. How much will be this one? So 0.5 into under root 1 minus 0.8 square. This will be equal to 0.3. So our desired pole is minus 0.4 plus minus j 0.3. Okay. So we'll calculate the angle of the system. You see, this is asking angle deficiency. Okay. So how much will be, it will be differ from 180 degree, that we have to calculate. Okay. Angle deficiency we have to calculate to design the compensator. So how we can calculate? We'll calculate the angle at this value. Okay. Then we'll add 180 degree, and that will be the angle. If at desired value, if some negative angle will be there, that much angle we should apply by the lead compensator to compensate that angle. Okay. So we can directly put this value in this one. So angle of G of S, okay, at S is equal to SD. So that will be angle of 2 divided by, what will be this value? So I'm this we can write as 2, I'm taking common. So 1 divided by S, this will be 1 divided by S into S plus 0.5. Is it correct? This 2 I have taken common from here. So it will be 1 divided by, angle of 1 divided by minus 0.4 plus j 0.3. Okay. And the second value will be S plus 0.5. So SD plus 0.5 means 0.5 minus 0.4. That will be how much? 0.1. Okay. Plus j 0.3. Is it correct? Now, is the values are correct? So from this one we can
Yes, sir. Yes, sir. Yes, sir.
we can find the angle. So angle for this will be how much? Minus 4 plus j 0.3. Minus 4 minus 0.4 plus j 0.3. That will be, so again it will go on in numerator, it will be minus. So minus I am multiplying here, minus 180 degree minus tan inverse. This will be 0.3 by 0.4. So 0.3 by 0.4. Okay. This is the angle from this one. What will be this one? So 0.1 plus j 0.3. Okay. So this will be the angle. So this will be, it will be in minus only. So here we can write directly minus tan inverse 0.3 by 0.1. Is it correct? So this will be the angle at the desired pole. Is it clear to all up to now? Hello.
Yes, sir. Yes, sir.
Okay. Okay. So what will be this angle? I'm just calculating. You can also calculate. So the angle will be tan inverse 180 degree minus tan inverse 3 by 4. 3 by 4. One second. So this is 143 point. So minus 143. This is minus 143.13. Okay. And this is one second. Minus tan inverse 3 by 1. So tan inverse 3 minus 71. This will be minus 71.56. So total will be plus 143.13. So total angle will be phi at this desired pole will be, phi at SD equal to minus 214.69. Okay. This will be the phase. So phase margin, how we can calculate? 180 degree we can add at that value. Okay. So so how much will be the phase deficiency? We can add in 180. So angle deficiency will be is equal to 180 degree minus 214.69. So this will be equal to minus 34.69. Is it correct? 214 minus 180 minus 34.69. So this will be the angle deficiency. Is it clear up to now?
Yes, sir. Yes, sir.
Okay. So this question is completed. Now next question, coming to the next question. Okay. So already we have calculated the angle deficiency. Okay. Now for that angle deficiency, we have to calculate the magnitude of the lead compensator. Okay. And magnitude of the lead compensator 0 and magnitude of the lead compensator pole. Okay. So already we know the SD. What is our SD desired? 0.3 minus 0.3 plus j 0.4. This only was there. Minus okay, minus 0.4 plus j 0.3 minus 0.4 minus 0.4 0.3. Okay. So what will be the theta value for this one? Can anyone tell what will be this theta? So theta will be equal to tan inverse 3 by 4. Theta is equal to tan inverse 3 by 4. Okay. How much will be this value? Theta will be equal to 36.86. This will be equal to. So this formula we should remember. Okay. This all formula, like for a standard for designing of the lead compensator. So we should know these parameters. Okay. That gamma is there. Gamma is equal to 1 by 2 into 180 degree minus theta minus phi. Okay. So this phi is what? Deficiency. Okay. Already we have calculated angle deficiency phi. So that is how much? If it is coming as minus, so that thing will be angle deficiency is 34.69. The answer will be plus, I think. No, minus only, but here it will be plus. So answer will be minus only. Angle deficiency, this much deficiency is there. Okay, minus 34.69. But here same phi we have to put. Whatever will be the angle deficiency, that minus 30. How much that value? 34.69. So this will be 34.69. Okay, and this theta will be in from this one time specification. So theta will be 0.3 divided by 0.4. So this detailed concept you can refer the NPTEL lecture. Okay, from there how it will be, how this formula will be derived, it will be given there. So we can calculate omega n. How much we have calculated already? Omega n is equal to 4. How much was the omega n? Omega n 0.5, here it was 0.5 only. See, from here also we can see 0.4 and 0.3. So what is omega n? Omega n is this length only. So omega n is equal to 0.3 square plus 0.4 square. That is how much? 0.5. Is it correct? Hello. So omega n is equal to 0.5. Gamma value we can calculate. So gamma is equal to 1 by 2 into 180 degree minus theta is how much? 36.86. 36.86. Okay, minus 34.69. How much will be this value? Gamma? Can anyone tell? I'm also calculating. So 1 by 2 into 180 minus 36.86 minus 34.69. 54.22 we are getting. Is it correct? Can anyone reply? Hello? Am I audible? Anyone can write in chat box also?
Yes, sir. Yes, sir. Correct, sir.
Okay, okay. So ZC we can calculate what will be the 0 of the this one. So ZC is equal to omega n. Omega n is 0.5 into sine of this gamma value 54.22 divided by sine of 54.22 plus theta, how much we got? 36.86. Okay, so it will be 0.5 into sine 54.22 divided by sine 54.22 plus 36.86. How much we are getting? Is it 0.405? 0.405. Everyone is getting this value? Hello? Is it correct?
Correct, sir.
Okay. So similarly, we can calculate the pole value also. ZP will be equal to 0.5 into sine 54.22 divided by sine, okay, and then gamma plus theta plus phi. So that will be, gamma is how much? 1 second. 54.22 plus theta 36.86 plus phi here will be how much? Phi is 34.69. Okay, so just one value we can just add, 34.69. Much we are getting? Gamma plus phi. At top also we have to add phi. 54.22 plus phi how much? 34.69. 54.22 plus 34.69. 0.616. This will be 0.616. So magnitude of the this 0 will be 0. The pole. So pole will be how much? Pole will be 0.616 and 0 will be 0.405. Is it correct? Pole will be
Yes, sir.
0.616 and 0 will be 0.405. So our transfer function will be like the G of lead will be equal to S minus. So that will be like in the right hand side only we are getting pole and 0 location. Okay, so that will be S plus 0.405 divided by S plus 0.616. This is our lead compensator. Okay, so okay, so coming to the next question, is it clear to all up to now? So we have to
Yes, sir.
Yes, sir.
remember this all formulas. Okay, so maybe similar kind of question will be there in your assignment also. Have you seen that week 7 assignment? Any questions are there related to this? Hello? Is it clear up to now? Should I move to the next question?
Yes, sir.
Yes, sir.
Okay, okay. So with the whatever the pole and 0 we have computed, with the pole and 0 of the compensator as derived above, what is the compensator gain that will achieve the desired performance? Okay, so compensator gain. So compensator transfer function is Kc into S plus Zc divided by S plus Zp. This is our compensator transfer function. What is our plant? Plant already given here. Plant was the S by S into that will be S by S into S plus 0.5. No, 1 by S into S plus 0.5. So our plant is GFS is 1 by S into S plus 0.5. So what will be the compensated? Compensated will be this into this. Okay. So that will be K, let's say this is K compensator gain into S plus ZC. So S plus ZC is how much? 0.405. Okay. Kc into S plus 0.405. Okay. Divided by S plus ZP. S plus 0.61. How much? 616. Okay. 616. Okay. And our transfer function is 1 divided by S into S plus 0.5. So see here, whatever the formula I have explained in the first question, that will be more clear here. Okay. So I am going to calculate the K value with both the methods. With root locus, I will calculate, and with the normal method. Okay. So here we have to calculate this value. Okay. So how we can calculate for the desired performance? What is the desired performance? That is this one, S of T. S of D we have to go. What is S of D? This one, minus 0.4, okay, plus J 0.3. So minus 0.4, our desired pole is SD is minus 0.4 plus J 0.3. So what will be the, how we can calculate this one? This is our compensated transfer function, and to achieve that criteria, that peak overshoot and all, we should put this one, okay, in this whole compensated. So magnitude G of compensated S at SD, this should be equal to 1. Okay. So if we'll apply this criteria, we can find the compensator Kc. This is compensator again, we can find the value. So first we'll draw the root locus for this one. Okay. So 1 second. One pole at 0, one at 0.5. Okay. So one at 0. 1 second. At 0, one at minus 0.5. Another at minus 0.616. Minus 0.616. Okay. And where are the other? 10 is at 0.405. Okay. Minus 0.405. So where will be that? Here will be that 0. Okay. So what will be the root locus? 0 minus 0.5. This is that minus 0.405. So this is minus 0.405. Okay. And our desired pole is minus 0.3. Correct. Minus 0.3 plus J 0.5. That one, you know. Minus, no, minus 0.4 plus minus J 0.3. Minus 0.4 plus minus J 0.3. Okay, this is our desired pole where we have to find the K value. So, 1 second. So, number of pole, what is the number of asymptote? So, that is 3 minus 1. That is equal to 2. Right? And here root locus will be there in this one. What is the rule? If odd number of thing will be there, what is the centroid? First we'll calculate the centroid. Okay. Centroid is how much? Can anyone tell? Sigma real pole minus sigma real zero divided by number of pole minus number of zero. Okay. What is real pole? Minus 0.616 minus 0.5 correct? Minus real for 0. So minus 0.405 divided by number of pole minus number of 0. So 3 minus 1, correct? What will be this value? 1 second, I will also calculate. Minus 0.616 minus 0.5 plus 0.405 divided by 2 minus 0.355 we are getting. Is it correct? Hello.
Yes, sir. Yes, sir.
So the centroid is minus 0.355. 1 second. So that will be here. Like somewhere here it will be. But something is 0.5. This is very nearby value, na? That is okay. So how I think this will be? I think this section root locus will be there since this side. So this pole will end at here 0. This 0 I think. This pole will end here. Okay. And this 2 it will come something like this. And after that it will go like this. Okay, this will be leave that. So we have to calculate what value, some at this value we have to calculate the k. Okay, so where will be this value? At minus 0.4, somewhere it will be here. Let's say this is minus 0.405. Okay, minus 0.405, somewhere it will be here only. Let's say minus 0.40, so almost I am assuming on this line only it will be there. Okay, so let's say somewhere it will be here. So this distance, okay, this distance, okay, this all three distance we have to calculate. Okay, and from pole also we can calculate the distance. So one by one I'm going to calculate. Okay, so the x-axis is 0.4. From here, if you'll see from 0, what will be this length? So for this one, minus 0.4 plus j 0.3. Okay, so how much will be this length? That will be 0.5, correct? This length one will be 0.5. Is it correct? Okay. So second will be this length I am calculating under root 0.3. So 0.3 square plus 0.616 minus 0.4 square. Is it correct? Zero point 0.3 square plus 0.616 minus 0.4 square. 0.3696. 0.3696. This from this point to this distance 2. Again this distance we can calculate third one. So third one will be, this one will be under root. See, y-axis will be same. Y-axis will be 0.3 only. Only we have to find the x-axis. So whatever will be this value minus 0.4, correct? So that is 0.3 square plus 0.5 minus 0.4 square. Is it correct? 0.5 minus 0.4 square. 1 second. So this I am get 0.316. 0.316. So all distance from the pole we have calculated up to this point, desired point. Okay. From all 0, what will be distance? So our 0 is minus 0.405. Okay. So it is greater than 0.4. Okay. So the distance will be equal to, the 0 distance will be equal to, that will be equal to under root 0.3 square plus 0.405 minus 0.4 square, correct? it will be almost equal to 0.3 only, but a small portion 0 also I have taken. Okay, is it clear to all up to now? Hello.
Yes, sir.
So this is almost equal to 0.3 only, 0.3 only. But if we'll calculate the actual value, that will come as 0.3000416. Okay. So now K value we can calculate. So K will be equal to product from all the pole. Okay. So 0.5 into 0.3696 into 0.316 divided by 0.300416. How much is this value? 0.5 into 0.3696, so 0.316 divided by 0.300416. We are getting 0.19438, 0.1948. So this is our K value to achieve this response. This kind of desired pole we need. So for this pole, is it clear to all up to now?
Yes,
Hello.
sir.
Okay.
Yes, sir.
So see here when 0 was there, so that 0 will be come in denominator. If 2 0 will be there, so distance from both the 0 will be computed till the desired point. Okay. And that both will be multiplied in the denominator. Okay. So now we'll see the same thing with magnitude criteria. Okay. Already magnitude criteria I have told. So this is the magnitude criteria. GCF SD should be equal to 1. Okay. So the magnitude criteria is GCF SD, this should be equal to 1. Our transfer function is S into Kc into S plus 405. Okay. Kc into S plus 0.405 divided by S plus 0.616 S into plus 0.616 S plus 0.5. So this whole magnitude at SD is equal to how much? Minus 0.4 plus j 0.3, minus 0.4 plus j 0.3. This should be equal to 1. Okay, so this is the magnitude criteria we can apply. Oh, so I'm just going to put all these values. So Kc into how much? This is minus 0.4. So minus 0.4 plus 0.405. How much? That will be 0.005 plus j 0.3. Correct? The same thing. So what will be here this value? Minus 0.4 plus j 0.3. First one. Okay. What will be the second one? The second term. So that 0.616 is there. So 0.616 minus 0.4. How much?
0.216, sir.
So 0.216. So 0.216 plus j 0.3. Second one. And what will be the third one? So 0.5 minus 0.4, 0.1 plus j 0.3. This is the magnitude. See, directly if you'll see, same here also it is doing the same thing. Okay. What is happening? K is equal to, this is the length from all the poles. So if see, objective question will be given, sometime that the pole information will not be given and you will know the distance from the, so directly we can apply this short trick. Okay. So now we can calculate this all one by one. What will be the value? So we can write Kc into what will be the magnitude for this one complex number? Under root a square plus b square. What will be that value? 0.3 square plus 0.005 square. 0.3 square plus 0.005 square. That's same 0.3000416. 0.3000416. Okay. What will be this value? 0.5, 0.4 square plus 0.3 square. Again 0.216 plus 0.3 square. So 0.216 square plus 0.3 square. How much? 0.3696. So into 0.3696 into again 0.1 square plus 0.3 square. So 0.1 square plus 0.3 square. How much? 0.3162. 0.3162. This is our magnitude. This should be equal to 1. So same thing is happening here. Like this will go in numerator. So Kc will be equal to, compensator will be equal to 0.5 into 0. 1 second, just I will omit this one. 0.5 into 0.3696 into 0.3162 divided by 0.3000416. Correct? So we'll get the same value, whatever we have calculated earlier, 0.19438. 0.19438. Is it clear to all? Hello?
Yes, sir. Yes, sir.
Okay, okay. So this was the last question for today. If you have any other doubt related to today's session or any other the general doubt related to control system, you can ask. Hello? Any doubt in today's class, today's session? Now this concept is clear, this one, like how distance is multiplying. Hello?
Yes, sir. Yes, sir. Actually, it was told earlier also, sir, how to
Earlier
find K.
already I explained. So again, I kind of a revision.
Okay, sir.
So
Okay.
okay. So any
Okay,
other
sir.
doubt?
Good night, sir.
Okay. So thank
No,
you
sir.
all.
No, sir. Thank you. Thank you, sir.
Okay. Thank you all. We'll meet on the next Sunday. Thank you.